Okay, so topic 2, we're going to continue on with talking about systems. And we're actually going to start with just a quick review of yesterday, which is to solve systems by graphing. So I'm actually going to pause the video here right off the bat and do number 1. And y'all pause it as well. And just graph number 1 on the graph provided and find the solution, which is the intersection point. So go ahead and pause the video now. Okay, so I've graphed my 2 lines, and I can see that their intersection point is right down here at -2, -4. So that is the solution. So we're going to do the exact same thing for 2 and 3, but you'll notice that the things have gotten a little bit more difficult today because they don't all look like y equals mx plus b. So on number 2, we already have y equals 5x, so that's ready to go. So I've got a y-intercept of 0, up 5/1, down 5/1. You know, it's horrible. If at some point y'all could all rally together and get me enough money to buy a new smartboard. I'm just kidding. Don't do that. Okay, so pretend that goes through the points. Y equals 5x. The next equation, though, does not say y equals mx plus b. So I'm actually going to multiply everything by 5 to get rid of my fraction. And I get y equals 5x plus 35. Okay? Well, you can already tell there's a problem here. 35 is not going to fit on this graph. But I can already see something else happening here. I have a slope of 5 in my first equation and a slope of 5 here. Well, what do we know that means? That means that these lines are parallel, right? So even though 35 is way off this graph, I'm going to go ahead and just draw a line that is generally parallel to my red line. Okay? I know it's not perfect, but pretend. Just glancing at that, if the whole point is to try to find their solution, which is their intersection, are they going to have a solution point? And the answer is no, right? There's no solution to this system, okay? Which we've had this kind of stuff before, right? When we're solving equations, sometimes we'd have no solutions or all solutions. In this case, there's no solution because these 2 lines are parallel, okay? So again, keep on trucking. Number 3 over here, I need it to look like y equals mx plus b, so I'm going to add 3x to both sides. My first one, so -1, up 3/1. Okay, then I go to make my second equation. I need to solve for y, so I'm going to divide by 6, so y equals 3x minus 1. Well, there's -1, there's my slope of 3. This looks familiar, right? What do we know? It's literally the exact same line, written twice, okay? So if I was to say, well, what are the intersections here? Well, it's literally intersecting at every single point, okay? Now, you might be thinking I'm going to write all real solutions, but I'm not going to, because it's not every solution. For example, -3,1 right here, that's not a point that will work. That's not a solution. But every point that's on these lines will work. So instead, I'm just going to write the word infinite solutions, because there are an infinite number of solutions to this system. I can't just write one of them, but I don't want to write all because it's not actually all of the solutions in the world. Okay? So what we just have discovered is that there's 3 different types of systems. We have intersecting systems, parallel systems, and coinciding systems. Coinciding is when it's literally the exact same line. So I'm just going to kind of sketch what these look like. Pretend that's more parallel. Okay? And then we're going to write how many solutions each of these types have. If it's an intersecting system, there is 1 solution point and that's it. Okay? If they're parallel, there are no solution points at all. And if they're coinciding, there are infinite solutions. Now, just because they're infinite solutions does not mean it's every solution. There's just an infinite number of them. Okay? These lines underneath are for us to come up with some examples of this. So for example, let's go back to coinciding. If the first equation in the system was y equals, I don't know, 3x minus 18. Well, in order for it to be coinciding, that means the other line has to also be y equals 3x minus 18. Okay? It may not look like that right off the bat, But if they become the same y equals mx plus b, it's coinciding. So parallel, let's say the first line is, I don't know, y equals negative 1/2 x plus 7. Well, for it to be parallel, I need to also have negative 1/2 x, but then I don't want to, hey Piper, shout out in your video, I don't want to have 7 again because that'd be coinciding. Instead, I just want a different y-intercept. It can be anything. So I'll write like -4. Just made it up. But they have the same slope that shows they're parallel. Okay, then intersecting, last one. Let's say our first equation is like y equals, I don't know, 3/4 x minus 12. Well, the second equation is just anything else. It does not have to be perpendicular. That's kind of a misconception people make. It could be literally y equals 1/8 x plus 9 or something. As long as the slopes are different, these two lines are going to intersect. It does not have to be perpendicular. It's just two different slopes. Okay? So there's our 3 types of systems that we have and how many solutions result from them. So looking at your notes, we then want to find, well, how many solutions would these 3 situations have? So we're going to predict that just by looking at the y equals mx plus b and saying, oh, well, that's the same line, so it's going to have infinite. Or, oh, those are parallel, so there's going to be none, etc. So looking at number 4, the only way we can do this is if I solve it for y equals mx plus b. So on the top here, I'm going to subtract x from both sides. Over here. So I've got 1/3 y equals negative x minus 10. Then I need to get rid of this 1/3, so I'll multiply everything by 3. So y equals negative 3x minus 30. So there's our first equation. Okay, second equation, I need you to move this 3x over. So I've got y equals negative 3x plus 30. Well, comparing those two equations, they have the same exact slope, but not the same y-intercept. So that means that this situation, we have parallel lines, okay, which means that there are no solutions. Okay? Now, middle problem, number 5 here. Same thing, I want to solve for y equals mx plus b, so I'm going to divide by 2. So y equals 3, I've got a hoy here. Then the second equation, I'm trying to get y by itself. So I'm going to divide by 3 first. It's like the bodyguard. So x plus y equals 4. Then I just have to move my x over. So y equals negative x plus 4. Well, those are 2 completely different lines. They don't have the same slope. They don't have the same y-intercept. They're literally just 2 different lines. So these would be intersecting. And there would be one solution. One and only one. Okay, last one, you could probably guess, but let's work it out. Subtract my x from both sides, so y equals negative x plus 2. Then I need to subtract my 3x over and divide by 3. So 3y equals negative 3x plus 6. Divide by 3, y is negative x plus 2. Well, again, these 2 equations are literally the exact same thing. There's no difference at all, so that means this is coinciding. And there are an infinite number of solutions. Okay? Infinite number. So that's how you make predictions about systems. We will eventually learn how to solve them, so you don't really have to make a prediction. But if you're just curious in knowing what kind of system it is, that's how you would do it. You would solve them for y equals mx plus b and check to see how many solutions it looks like it's going to have. Alrighty? So the other part of today is just writing systems, writing the equations themselves. The good thing here is that you're not really having to solve for the rest of the notes. You're just writing the equations themselves. So as we learned yesterday, a system of equations is an algebra problem where 2 equations are working together, right? You have to have 2. So a system of equations will have 2 variables, x and y. At least in our class they will. But before you can write them, you must first define the variables. Oh, another shout out. Hey, Shweta. Okay. So looking at number 1 here, we have this story about Rebecca. It says first we need to define our variables. Let's read the story. Rebecca bought some apples for 50 cents per pound and some oranges for 75 cents per pound. She bought a total of 10 pounds of fruit and spent a total of $5.25. How many pounds of apples and oranges did she buy? It says first assign labels to x and y. The easiest way to do this is to look at the question. It says how many pounds did she buy? So X would need to stand for the pounds of, we just pick one, apples. And Y would need to stand for the pounds of oranges. Some people get confused and they might say like the cost of apples or the cost of oranges. Well, they already told us that. They wouldn't ask you for it if they already told you the answer. Okay, so now I set up the equations, and you'll notice it says one equation will have the money numbers, and then one's going to have the pound numbers. So let's start with the money. It says she bought some apples for 50 cents per pound, and so I'm going to add to that oranges for 75 cents per pound. Then, blah, 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 she spent a total of $5.25. So there's our first equation that kind of gives us her cost setup, per se. The other equation, they also told us she bought 10 pounds of fruit, right? So when we add up all of her fruit, it's supposed to be equal to 10. Well, X and Y literally stand for the pounds. So the pounds of apples plus the pounds of oranges should be 10. And there's our two equations. Okay, we're not going to solve for now. And you'll notice on your homework, you're not going to solve hardly any on your homework either. You're just going to be writing equations. So let's look at the next one. Justin has a total of 35 dimes and quarters, so 35 coins total. The coins add up to $5.75. How many dimes and quarters does he have? Well, again, we're first going to define the variables. So the question is, how many dimes and quarters does he have? So X, I'm going to say, is the number of dimes, and Y is the number of quarters. Okay. Before we write the equation, let's come over here to this little box. What do we know about dimes? They're worth 10 cents each, 0.10. Quarters, 0.25. Just for kicks, nickels, 0.05. Right? Just throwing that out there. Okay. Now we're going to set up our equations. One's going to, again, talk about the money and the value, and the other's going to be like the number, the amount. So they say that he has a total of 35 dimes and quarters. Okay? Well, if our variables stand for the number that he has, X, all the dimes, plus Y, all the quarters, there should be 35 coins total. There's our first equation. But they also told us that it was worth $5.75. So the 10 cents for every dime plus the 25 cents for every quarter, that should equal $5.75. There's your two equations. Okay. Number 3, you'll notice that there's not blanks and stuff written down, but we're still going to do the same steps even if there's not blanks. So it says Monica built a porch that contained 2 different colors of bricks to create a neat pattern. She purchased the red bricks at $2 each and the gray bricks at $3 each. How many red bricks did she purchase if she spent $160 on 60 bricks? Well, again, the question helps us define our variables. How many red bricks? I'm going to define over here, let's say X is the number of red bricks, which means that Y would be the number of gray. And then I'm just going to write 2 equations using the information they gave us. First thing I see is the cost. So red bricks were $2 each, so 2X plus 3Y should equal the cost that she spent, which is $160. Then we also know that she bought 60 bricks total. So X bricks plus Y bricks should be 60 bricks altogether. And there's that one. Okay. Last one. The sum of 2 numbers is 36. Their difference is 6. Find the numbers. This would be the only instance where defining the variables would be kind of weird, right? Because what does X stand for and what does Y stand for? Well, X stands for a number, and Y stands for the other number. They're not really referred to in a story, so there's not a lot you can define there. But it doesn't hurt to write those on there. So now, reading it again, the sum of the 2 numbers is 36. So X plus Y should be 36. Their difference, X minus Y, is 6. Checkity check, we're done. Okay? So again, when you read through your homework, look at the instructions, because most likely for today purposes, we're not going to actually solve these. We're just wanting to write the equations just to kind of get that practice. The last thing we're going to do is write equations from graphs and tables. And you have already been doing this when you were doing your Desmos project, just the past couple of units that we've had about linear equations. You kind of already know how to do this, but this just shows that sometimes you have 2 at a time because it's a system. So number 5 says, given the graph, write the equations and give the solution if there is one. So starting with this pink line, it's a horizontal line, it's a HOI. So my equation would be y equals 3. Moving on to this blue line, it's not a HOI, so it's y equals, I can tell my slope is up 1 over 2. So 1/2 x, y-intercept is 1. So there's my system. And then they asked for the solution. Well, there's the intersection point right there, 4, 3. There's my solution point. The same thing on the next one. Again, you could probably pause, do this yourself if you'd like to. We're just going to keep on trucking. But feel free to pause if you want to try this one on your own. This first equation right here, I can tell my slope is -1, so negative x. My y-intercept right there is 2. Okay, other equation down here, y equals, I can tell my slope is up 2 over 1, so 2x. Y-intercept is 1, 2, 3, 4, 5, 6, -7. So there's my system. Intersection is the solution, and that one is at 3, -1. Again, easy peasy. The last thing is to do the same exact process, but from tables. And again, you've been doing this for the past few weeks. So we're going to write the system and then give the solution if there's one. So left-hand side table, that's +3. That's +1. So I know my slope is y equals 3x. They gave me a y-intercept, which is very nice. So y equals 3x plus 5 is my first equation. This next table, got +6, +2. So I know my slope is, again, 3. That's interesting. I don't see the y-intercept in the table, but you can work backwards to find it pretty easily here. We're just subtracting 6 up the table, so I get -2. There's my system, but then let's talk about the solution. Well, when I see y equals 3x plus 5, y equals 3x minus 2, that means that they are parallel, so there is no solution. Okay? No solution at all. Last one, number 8. This is a different looking kind of table, but just visually, you'll kind of have to just split it in your eyes. These 2 columns together is one table that you'll work with, and then the first column and last column together make your second table. So let's start with the first 2, and let's just figure out their slope and their equation. So this would be +3 plus 2, so my slope would be y equals 3/2 x. They do have the y-intercept for me right here, so -2. Then let's use the first column for x and the last column for the next equation. I'm going to move down a little bit just so I have room. For example, right there it says +4, this would be +2, so my slope would be y equals 2x. And again, using the 0, I can see that my y-intercept is -5. So there's my system, but now I need a solution. These are not parallel lines and they're not coinciding, so there is a point that they would intersect at. Well, if you look at this table, if they're intersecting at the point, that means it's the same for both of them. So for example, just this first point, -4, the first graph is at -8, second graph is at -13. That means that they are not both intersecting at that point, right? If you keep reading, keep reading, keep reading, you'll see down here where we're at the 6, the first equation is at 6, 7, at the same time that the second equation is at 6, 7. Okay, so my solution has to be 6, 7. So you just kind of look and see where are they the same at the same time. Okay, so hopefully at this point you can write a system, whether I give you a graph or a table or a story, and then hopefully you can predict the solutions by looking to see, oh, these lines are parallel, oh, these lines are coinciding, etc. Okay, so let me know when I get back if you have any questions. Don't forget your line project. You want to have that done and ready to go tomorrow, so make sure you have emailed me any questions you have, you've looked at Schoology, you've looked at the requirements, you've got your poster ready to go, because that is due first thing tomorrow.